which is awesome because not all professors let me do that. So if you guys have any questions on the homework, just email me which ones, and I'll make a point to go over them during the sessions. Next one's Sunday at 7, and then Monday also at 7. So stop in, check it out, and then I work on the clock, so I can't help you 24/7, just during those session times. So yeah, I'll see you then.
All right. So that's actually really great. She said she has her session on Sunday and then Monday, and of course your homework's due Monday at midnight. So that would be a really great opportunity if any of you have any questions on your homework. You can of course email me. I don't promise if you email me like after 5 or 6 p.m. that I'll get back to you in time. So that's also another thing. If you have a question later in the night, it might be better to try to tag on to the SI session with Zoe. All right, so we're talking about linear functions still, and we should hopefully finish 1.2. We're already getting a little behind, imagine that. But it's all right. We're going to do something a little bit different today. We're going to be jumping over to a Desmos in a second to try to get you guys to answer some questions on your own instead of me doing it for you. Participation, yay! Everyone loves that. Anyway, but I did want to go over something really quick. So we kind of rushed through this last one, I believe. So I just want to go over that really quick and also to give us a refresher about how these are going because we'll have to use it in a second. So for this last one that we finished the other day, we needed to essentially find the line between the 2 points where t equals -1 and t equals 2. So to find the equation of the line, we need the full point though. So we needed to find the y values. So we took our x values, plugged them into the function we were given to find their corresponding y values. Once you have both full, I can't talk today, both full points, you go ahead and find the slope. So we take our y2 minus y1 over x2 minus x1, and we found that our slope was -0.25. And then remember to finish off these, when you have your slope and you have a point, or maybe multiple points, if you have multiple points, you get to pick which one makes you happier. So I personally chose that the -1/8 made me happier. And then remember what we do with that is that we take it into our y equals mx plus b format, plug in the point and the slope, solve for the b value, and then just write our final equation. So I am going to walk through the first one of this before having you try the rest on your own, but I do want to get you set up in the Desmos first. So what that's going to do is, so you're going to get set in and then pop back over to the Teams screen. You're not going to need to be going back and forth too much. Most of it will be in Desmos before we come back to Teams. But what you're going to need to do is you're going to need to open a web page. Go to student.desmos.com. Oh, you can't see this. I forgot that I'm specifically sharing OneNote. Nope, I shared OneNote again. Let me just share my screen. That'll be easier. Student.desmos.com, there it is. And then type in the code. It is not case sensitive, so if you put in all lowercase, you'll get there. So go ahead and jump over to another page, student.desmos.com 5ZPETH. You can log in with Google if you want to. You don't have to. And yay, people are already getting in. Woohoo! So I'll give you all like a minute or so. Try to get in there. You can kind of see it's essentially the questions on the notes, and you're just going to be typing in the answers for me. But just get in there. You can take a look around really quick, but then we're going to be going over to that in a second. All right. So jump back to the Teams call real quick. so that we can look at my OneNote real quick. Oh, the code here, let me write the code on the side of the OneNote. What is it? 5ZPETH. 5ZPETH. 5, that's not good. 5ZPETH. It's saying it's blocked. That's weird. Let me also make you all random mathematicians. Saying it's blocked. At what step do you get the blocked message? When you're trying to go to student.desmos.com, when you try to put in the code, what step in the process are we at? So let me bring up the little thing again. And the website is blocked? That's weird. So Gabby, what you can do, Gabby, these are literally just the questions from the sheet. So I'll have the sheet up on the Teams call, so you can just be doing them alongside us on paper. You don't need to necessarily be on Desmos. Oh, you got it? Yay! Oh my goodness, I'm sorry. My real estate agent is calling me. She knows I have class. Okay. Sorry about that. Different browser? Okay, cool. So jump back to the Teams call real quick. So what you're going to be doing for the first couple questions is filling out this question. But to go over kind of how this will work, so I'll fill out the first one for us. So for f of x, I know there's like a bunch of lines working out here right now, but we're working with essentially this one right here. And so with these ones, the nice thing is that we can actually pull off the slope and the y-intercept graphically. So essentially, remember, we need two things to write the equation of a line. We need a slope and a y-intercept, or a point if we can't find the y-intercept, but we can find the y-intercept here. So let's just go ahead and find it. So let's work with the y-intercept first. So if I'm looking at this graph, the y-intercept is where it's going to cross the y-axis. So it crosses the y-axis right there. And that's going to have a y value of -1 because it's one below that y-axis. So our b value is going to be -1. And then for my slope, I can do one of two things. I can either find two actual points on this graph. You know, I could find 2 points that are kind of nice and write both of the points out. So I'd have 0, 0, I'd have 0, -1, and 1, 0. And I could actually find the slope between these two using the y2 minus y1. Or you can look at it graphically. Now, graphically, you need to be a tiny bit careful. You do need to go between two nice points. So like, don't pick a point like the graph of h of x. You wouldn't want to pick this point over here because it's not really nicely, you know, in a little crosshair. But if we look at our graph, we've got a nice point here and a nice point here. And you essentially count how many over and how many up or down you have to go. So I go over 1, up 1. And so remember, it's change in y over change in x. I need to slow down a little bit. I'm too excited. Change in y over change in x. So our change in y would be how much we went up or down. So we went up 1 and we went to the right 1. So our slope would be +1. So then the equation of the line you were looking for, sorry, we're calling this f of x, would be essentially 1x minus 1, or just x minus 1, minus 1. So that's kind of how those go. Now be careful with the next one. The next one's actually a tiny bit tricky, but I want you to try it first. So those are the ones that I want you to try. So I want you to try essentially finding the other 3 equations, and then on the last slide on Desmos that you can see right now has the other questions as well. So I will leave this up for anyone who maybe couldn't get into Desmos, but otherwise switch back over to Desmos. You don't have to look at this Teams call anymore. I'll call you back over here if I need you. But pop over to Desmos, and I'll give you a couple minutes. I can also see kind of how you are working, so I should pull that up on my other screen so I can keep my Teams call up. But once everybody seems to be good, yeah, we'll do it. Also, you will be able to see some of your classmates' answers. Also, don't panic about that. You're all now anonymized, so you're all just random mathematician and scientific people's names. So no one will know it's you. So feel free to try to answer them to the best of your ability, and then we will go over it in a couple minutes. And one thing I will say about Desmos, the unfortunate thing, you can't press the enter key to go down to a next line. It really sucked. So you'll kind of just have to fill them out if it's got multiple things in a piece. Christina, that's because I haven't allowed it to let you go past screen 4. We'll go past that in a minute. You can't go past screen 1. Oh no. You should be able to get up to screen 4. Why can everyone else go, but you can't? um, oh, there you go. Now you're moving. Yay. So yeah, I'll give you maybe about another minute or 2 minutes. Most people are on the second screen. Some of you are getting to the third one. That's good. Good. I'm looking through these answers and most of you are getting them perfectly right. That's awesome. All right, let's give another minute and then we'll pop back over to the Teams call and write them out officially on our little sheet, and then we'll move on to the next part of the Desmos. So if you're done, you can pop over to the Teams screen again. But oh, I forgot to re-anonymize you guys. There we go. I know. I really wish they would fix that. I was trying to do it myself last night and I kept forgetting that you can't press enter to get to a new line, and it's a mess. All right, looks like most of you got through the last one, so let's pop back over to our team screen. I will scroll through the answers real quick. Again, most of you have the right ones up on Desmos, which is great. Maybe y'all were just pulling it from other people, but you know what? That's fine too. So I'll give you like 30 more seconds to pop over here. Not 30, maybe like 5. All right, so the first one we of course already talked about together. The second one, we've got this, straight across horizontal line here. So we've got a y-intercept up at 2. So we're going to have a b value of 2. But if you notice, we essentially go over and up nothing. We don't go up at all. So actually our b value is 2. So our slope would have a change in y value of 0. And then change of x could actually technically be anything. We could take it to be go over 1. We could take it to be over 2. It doesn't really matter because it's going to go up 0. So we'll have a slope of 0 there. So g of x is actually just 2. Some of you wrote 0x plus 2. That's perfectly fine. I usually never write the 0 because 0 is just 0. So g of x equals 2 or 0 times x plus 2 would both be correct in that case. For the next one, we've got h of x, so that was our only one that's going downwards. So we have our y-intercept at 0. So it crosses at the origin, so we have a b value of 0. And in this case, we need to be careful. So again, we need to make sure that when we're looking at the slope graphically, we go between 2 nice points. So I would pick the point at the origin, and then the next nice point is actually 2 spaces away. So we would go over 2 and down 1. Now, since it's down 1, and this might have tripped up a couple people because I hadn't mentioned it, when you go down, it actually counts as a negative. So that would actually turn our slope into a change in y over change in x. So our change in y would actually be a negative 1 over 2. So the slope there should be a negative 1/2. Some of you have a positive 1/2, which is good that you got 1/2. Don't wait, what? Negative. Okay, so you mean 1 over negative 2? It doesn't matter. So if you used those 2 points and found the slope that way, you might end up with 1 over negative 2. But 1 over negative 2 is the exact same thing as negative 1 over 2. It doesn't matter where the negative sign is. So it's still the same number, still negative 1/2. So either is acceptable. Technically, the way I found it is I went down 1, right 2 would be a positive 2 and down 1 would be the negative. So the way I personally found it would be negative 1 over 2. But if you found it a different way, you could definitely get 1 over negative 2 as well. So let's keep boxing these answers here. And then j of x, our last one. Are there any questions on these so far? I'm going through them slightly fast because you guys have already looked them over. And then this last one, again, most of you pretty much got. So we have our, where is it? There it is. Got our last one here. It has a y-intercept at 1. And then if we look for some good points to use our slope graphically, we would go over 1 and up 3. So we would have our b value being 1 and our slope, our change in x was 1, our change in y was 3, so that'll give us 3. So our function here would have been 3x plus 1. Questions, concerns on any of those? Oh, I didn't talk about the, well, questions about those before we go over the last set of questions. All right, and let me take a glance at the Desmos answers of this really quick. These also look pretty great. Awesome. Cool. Good stuff. All right, so for our questions down here, which function or functions has a negative slope? In this case, we only had one of them. It was h of x with the slope of negative 1/2. Which function or functions has the highest magnitude of slope? If you aren't familiar with the word magnitude, that's essentially the largest absolute value. So like, what's the largest numeric not concerning a negative? So that in this case would still be the largest positive number, which would have been 3, so j of x. Again, going through a little fast because most of you have gotten all this written down on the Desmos. Functions have a slope of 0 is just the one of g of x. Has the greatest vertical intercept, that was the one up at 2, which was also g of x. And then has the smallest vertical intercept was the one at -1, which was f of x. Questions, concerns on any of those? All right, so the next question is another bunch of kind of like little questions. So I'm going to open those up on the Desmos. So you should see slides 5 through 9 now, which is essentially the entire problem 6 on our notes. So I will give us 5-7 minutes to do those because some of those will take a little longer. But go ahead and try those. I'll have them up on the screen notes-wise in case you need them, but pop back to the Desmos and try to fill those out. Did I do something stupid? If you're talking about part I, f of x technically had a b value of -1, which would be less than 0. So in this case, we're just talking straight smallest. We're not talking magnitude anymore. So since -1 is actually smaller than 0, that one would quote unquote win and give us f of x instead of h of x. G. Part G. Which functions have a, so remember the slope is the m value. So we were looking for which one has an m value of 0, and that was the g of x. B is the y-intercept. So we don't care about the b because that's the y-intercept, not the slope. So that one we wanted the slope on, which was the m value. No, you're fine. So I will say you might have to think a little bit about some of these. So if you feel a little iffy on them, just try your best and we will talk about them. So maybe about 2 more minutes. People seem to be moving along pretty well. All right, just a couple more seconds. If you're already done, go ahead and pop back over to Teams, but I'll give you a couple more seconds. Some of you are just on that last one. And again, most of you are getting these perfectly right, which is awesome. I just realized that this recording is going to be very boring. Unless you look at the answers. Oh, man. All right, let's go ahead and pop back over to Teams, even if you're not quite done. Let's go ahead and talk about these. Maybe like 5 seconds to pop back over. All right, the first three were essentially just the generic ones. So we had our point slope. Let me move over here real quick. Our point slope, which is your whoopsies, your whoop, and I'm also, wow, okay. Your y minus y1 equals mx minus x1, where essentially the y1 is your y value of the point. The x1 is the x value of point. And your m is your slope. Slope intercept is our y equals mx plus b, where your m is your slope, and your b is your y-intercept. And then your slope formula is, of course, your y2 minus y1, or x2 minus x1. I'm not going to label the points of that one. I think it's kind of self-explanatory. And then we were asked to, so I went through those super fast because those were just regurgitating definitions, essentially. But if you want me to talk about them, let me know. Slope-intercept equation of a line with a slope of 4 and a y-intercept of 3/2. So that essentially just sets it up for you. You have your slope of 4 and your y-intercept of 3/2. So negative 4x plus 3/2. If you changed the 3/2 into a 1.5, perfectly fine, whatever floats your boat. So that one, we didn't really need to do too much work for that one. We just kind of put it in to the slope-intercept form. Equation of a horizontal line passing through negative 4, 7.3. So that's going to be essentially, so horizontal, am I stupid? I'm not. Okay, 7.3 would be somewhere up here. So essentially it's just going to be a straight line across. So essentially whenever you have a horizontal line, it's always just going to be the y value of whatever point you're going through. Like, because it's going to have that same y value everywhere. So a horizontal line will always look like a y equals something. So actually, let me write that down for notes purposes. Horizontal line will always have the form y equals some kind of number. Whereas with a vertical line passing through negative 13.5, that would be back here. And so essentially when you have a vertical line, it's just going to end up being x equals some number. This actually isn't a function. I should clarify that. It's a thing we can graph and we can talk about it, but this is actually not a function because it doesn't pass the vertical line test because it's a vertical line. So even though it's not a function, we can still talk about it, but it would have the equation x equals negative 13. X equals whatever x value that point needed to go through. This next one is probably the one that needed the most work because we actually need to find the slope and then the y-intercept. So if we find the slope here, I think this one people got tripped up on the tiniest bit in terms of some of the slopes. So be careful here. So we essentially have our 2 points, 1, 4 and negative 2, 13. I always prefer to put the larger y value on top, but whatever floats your boat. And so we would get 9 over negative 3. So we're reduced to negative 3. I saw some negative 1/3 in there. So just be careful. It's y over x. And then we've got y equals mx plus b. Pick which point makes you happier. I'm going to choose 1, 4 because, I don't know, I like the numbers better. So if you plug in that, plug in our slope of negative 3, x value of 1, you will get that b is 7. You should get the same thing if you use negative 2, 13. So your equation should be negative 3x plus 7, which most of you did. And I saw at least one person use point slope form, which is, point slope form, which is also perfectly acceptable. So good job there. And then this last one, the intersections of the line y equals 2. Well, that's going to be a vertical line up at y equals 2. and x equals -3/4, so that's going to be a vertical line at -3/4. So essentially it's going to intersect at -3/4, comma 2. It's going to intersect at the x value of -3/4 and the y value of 2. Questions, concerns on any part of that question? Okay. So the last thing we're going to do on Desmos is a card sort. So this one's going to look a little different. Let me pop over here real quick. If you're in the Teams thing, you can kind of look at Teams for a couple more seconds. So what you're going to do here is you've got a bunch of cards, and I tried to make the lines dotted and red so that if you can see red, you can see the red, and if you can't see red, you can hopefully see that they're dotted. And essentially, these are very generic formulas, but I want you to match them to a line that could have that equation. So what you can do is you can just drag the things that you think match, and then they'll pop together, and if you need to unpop it, you just unpop it. So go ahead and match those cards to the ones that you think match. So all of these letters are representing positive numbers. So if you see something like AX plus B, that's a positive slope and a positive y-intercept. And that's kind of what you're using to figure these out. Okay, I have a positive slope, positive intercept. What sketch of my options has a positive slope and a positive, intercept? So I'll give you 2 minutes on that. And then we'll talk about those. And then we have one last question in this set of notes. That is not on Desmos. At this point in time, there's only, now there's two. There's two people who have gotten them completely right. So if your fancy name is not Christine Ladd something or Grigory Margulis, Riley and Scott L. Ooh, Catherine's got it. Oh, Catherine is Maddie. Kurt Cottle. You might want to look over yours. I'm pretty sure it tells you your weird name like up in the left corner or something like that. All right, maybe another 20 seconds. And maybe I might actually do it out on Desmos before I plop them in the notes. All right, if you want to pop back to the team screen, it'll look like a Desmos screen, but it's a team screen. I will match these up on here and then we'll write them down on the notes so that they're there before I post them on Blackboard. So here, so let me kind of break it up like this. Let me do this real quick. Let me put all those up there. Let me do this, boink, boink, that, and then this. All right, so if we're looking at my screen now, I've kind of sorted them a little bit into I've got my two negative ones, my two negative slopes. Woo, didn't know that could happen. My two negative slopes, my two positive slopes, a third positive slope, and then my two, kind of weird ones. So let's go with the ones on the right first. So remember, a vertical line is always going to be x equals something. So that would be our x equals 2b option. And then a horizontal line is always going to be a y equals something not in terms of x, sorry. So since that has an x in it, that's not good. So we would want one without an x that's just y equals some number. So that one was a little tricky because it's not just y equals a or y equals b. It kind of tricked you up because it had the plus in there. But notice there's no x value on the right side. So that's the correct one there. And then notice the one positive slope one goes through the origin. So it shouldn't have a y-intercept. Well, it has a y-intercept of 0, so it shouldn't have a plus something value at the end. So the one that would match to is the y equals a over 2x. And then the remaining ones, so we have 2 positive slopes and 2 negative slopes, and we just need to then essentially pair them up based off of their y-intercepts. So we had a negative slope. This first one that I have here is a negative slope with a negative y-intercept, so that would be the negative b minus a. Negative bx minus a, sorry. And then the negative bx plus a would be the negative slope positive y-intercept. The one on my screen, the first one I have is positive slope positive y-intercept, so ax plus b, and then the ax minus b. So that's that. All right, so that's our Desmos. We're done with the Desmos, so you can close that out and pop back over here. So I'm just going to write down in terms of the ones on the notes which ones they were, so you can refer back to it later, but it's essentially exactly what we just went through on the Desmos. Questions, concerns on that question? Great. And as always, if you are typing something out and I'm just moving on, just keep typing and I'll go back to it. So we've got one last question, just enough time to go over the last question in this section. So we've got, and this one again isn't on Desmos, so you can just pop out of that. Suppose a new MyPhone cell phone costs $650 and depreciates in value $30 per month. A new Cyborg phone costs $580 and depreciates in value by $25 per month. Let m of x be the value of the MyPhone, x at x months after it was purchased, and c of x be the value of the Cyborg. Write formulas for mx and cx. So essentially with both of these, we have a starting value, and then it's telling us how it's changing over time. So essentially the starting value is going to be our y-intercepts. So our y-intercept for the MyPhone was 650, and the y-intercept for the c of x was 580. And so then the next piece, essentially the thing that's telling us what's happening per month, is going to end up being the slope. Now here, since it's depreciating, that means it's going down in value. So that would be a negative slope. So the MyPhone's depreciating by $30 a month, so we would have minus 30x. And then the Cyborg is depreciating by 25, so we have minus 25x. So say we have Carrie and Miranda buy phones. Carrie's going to buy the Cyborg and Miranda's going to buy the MyPhone. When will their phones have the same value? So if you want them to cost the same, we would essentially be setting these equations equal to each other. We want to know the month that makes these costs the same. So I want to set m of x equal to c of x. So 650 minus 30x equals 580 minus 25x. I like trying to make my x values positive, so I would personally add the 30x over to the other side first. You could, of course, there's a couple different algebraic ways you could go about this, but I don't know why there's a negative there. Hold on. And so that would leave us with a positive 5. And then subtract the 580. It'd give us 70 equals 5x. Divide both sides by 5. Got x equals 14. So they will have the same value after 14 months. I'm running out of time, so I'm rushing a little bit because I really just want to get this done. If we want to know when they will both be worth nothing, We're essentially setting them both equal to 0. So I'm going to breeze through that kind of. If you have questions, feel free, ask me. But I'm going to breeze through this a little bit so I can get it written out. So we essentially have that the my phone's going to be worth nothing after about 21 2/3 months. You could leave it as a decimal if you wish. And then the cyborg is going to be worth nothing after 23.2. Well, I guess if I made the other one a fraction, I'll make this one a fraction. 23rd and 1/5 months. I'll scroll back up in just a second, but at this point we're at the extra problem, so this is where we stopped for this. So we're going to be moving on to 1.3 next time, and hopefully we'll start moving a little faster because moving this speed is not going to get us through enough. So we'll start 1.3 on Monday. Your homework's due Monday night. It's only covering 1.1 and 1.2, so you don't need 1.3 at all. I try to make sure that everything that's on your homework is covered by Friday. So there's some things that you might not be able to get to at the beginning of the week, but by the end of the week, you should be able to do all the homework. Anyway, I'm a minute over. If you need to leave, feel free to. Peace out. Have a great weekend. I'll see you on Monday. If you have questions, feel free to stick around for a little bit. Otherwise, I'll see you on Monday. Have a great day. Thank you.